Thank you, John. And thanks to the MultiCycle Consortium for inviting me for this lecture. No, it's not really a lecture, it's more a presentation on trends in food packaging. So what I would like to do is go with you through some trends in food packaging and relate them with some projects indeed that we are at this moment performing. So I would briefly like to introduce to you our organization. So we are an organization, non-profit organization, founded in 2005 with the aim to bring together, on the one hand, all stakeholders involved in food packaging. That means food producers, packaging producers, producers of filling machines, and so on. So at this moment, about 60 companies are a member of our organization. And one of them is also Amcor, by the way. And we want to link those companies with research institutes, not only local, but also international research institutes, which have expertise in different areas around food packaging, food sciences, packaging sciences, and so on. And our main activity is in fact initiating and coordinating research projects on common needs identified through our or in our network of companies. And I would like to today show you some of those projects. So we in fact, we always start from the food product. That's also why our name is Pack for Food. We start from the requirements that the food product have in terms of shelf life. What are the factors that are determining the shelf life? Is it oxygen? Is it light? Is it water? Is it a combination? And based on that, we look for suitable, suitable materials that combine convenience and combine sustainability, but also taking into mind that we have to guarantee the shelf life to maximally reduce food losses. In 2019, we in fact indeed launched a roadmap called Food Packaging of the Future. This was together with 4 spearhead clusters in Flanders. And we did that in close interaction with more than 60 representatives from companies, research institutes, federations, other stakeholders. And through brainstorm sessions and so on, we identified, in fact, more than 50 innovation trajectories that should prepare food packaging for the future. And in our terms, future means 2030. It should, of course, be no surprise that one of the main topics was circular packaging, but also smart and personalized food packaging and packaging and logistics were very important topics. We made also a visualization of this roadmap. So with regard to circular food packaging, 4 main topics were identified. Eco-design, I will talk to that later on. Improved packaging, why not for certain food products try to extend the shelf life by using more advanced packaging materials. But also then 2 important topics on sorting and on recycling, trying to efficiently as possible sort and recycle. You also see here the other topics, I'm sorry, but in respect of time, I will not go more deep on that. So we will focus now on these 4 topics. I want to do that by giving you also some 3 key messages, and I think most of you will know those 3 key messages. But that is also a little bit our, let's say, our general topic within the activities of Pack for Food. So the first key message is that we always need to consider the packaged product, the product together with the package. It's the package that is protecting the food. In relation to that, there is at this moment running a project called Circopack. It's a project together with 24 companies, really making a toolbox to make it possible for food companies, but also for packaging companies to select the optimal packaging material for a certain food product. For example, take unpeeled potatoes. Should we pack that in a polyethylene bag, a bio-based polyethylene bag, or either in a paper bag? And we do that together with all these research partners. We do that by performing, amongst others, environmental impact studies. A second main or what I would like to say as well about Circopack is that we defined short shelf life, medium shelf life, and long shelf life food products because all of these categories have need other requirements with regard to the packaging material. We also take into account in this project some de-inking processes, mechanical and chemical recycling, and the project will last until June this year. The final objective is to make an online tool where companies can start themselves calculating the environmental impact. The second key message is related to eco-design. Try to aim for packaging optimization. And in terms of that, I think most of you will know the 4 R's. Sometimes you hear 7 R's, other times 9 R's. I will keep it to 5 R's. Remove, reduce, reuse, recycle, renewable. And I will pick out some of those. For example, with regard to reduce and recycle, there has been a project in 2015-2019 with more than 60 companies on finding the optimal packaging composition for certain food products related to gas barrier, light barrier, and also functional barrier against migration. And I will give you one example of one of the achievements in this project. Think about a short shelf life product, think about a ready-to-eat meal packed in 3, so it was kind of a vol au vent, packed in 3 different types of trays. The reference tray that was currently used by the food company that was involved in OptiBarrier. There were many food companies involved, by the way. And then 2 alternatives. And then the question is, can we reach the same shelf life by using an alternative compared to the current one? So basically what has been done is, so here you see the picture of the ready-to-eat meal. So what has been done, and specifically here at the Ghent University, different storage experiments were performed in all these 3 packaging materials. And then, for example, one important factor here is the ingress of oxygen. We want to have as less as possible ingress of oxygen. And then if you compare the reference with the 2 other packaging materials, the alternatives perform better. Now you can also ask yourself the question, how is it possible that even the orange one could have a good shelf life, a shelf life in this case of 2 weeks? Well, you see that in the other graph. This is a graph showing the growth of lactic acid bacteria. These are the bacteria that spoil the product, make the product acid. And then you see no difference at all between the 3 different packaging configurations. So in the end, for this type of product, it could be concluded that instead of using this one, we can use this one, which is completely monolayer and which is more easy to recycle compared to the other one. That's a little bit the idea of the whole OptiBarrier project. Another example, for example, was I will skip that one. Another example was the sliced cheese. So sliced cheese has been packed in different types of materials, as you can see. And in the graph, you see the evolution of oxygen in the headspace of empty trays, just to show you the differences when you play with the composition of your packaging. When we did then the real shelf life test, we saw that this one was not good at all. You can already see that from the oxygen evolution. Too much oxygen entered the pack, so after a while we had mold growth, visible discoloration of the cheese. But the other ones performed, in fact, and especially if we compare this one together compared to this one, the reference, then also this one had the same shelf life. Again, you see that this structure is not so complicated, so more easy to recycle than the other ones. So it's about OptiBarrier. Another one closely related, the name is closely related to MultiCycle, multi to recycle, but it's a little bit a different approach. So what this project has started recently, a couple of months ago, and it's about the balance between, on the one hand, the presence of barrier materials, and on the other hand, the recyclability. So what we want to do is, we look specifically to polyolefins, more specific to polypropylene, because sorting and recycling companies in Belgium asked us to focus on polypropylene, because at this moment in Belgium, there is no separate stream for polypropylene. And in fact, this should change. So we hope that this project will give an answer to that, or part of the answer. So we focus on coated polypropylene, for example, with the metallization, polypropylene with, for example, EVOH, but also different types of polypropylene like OPP, COSPP, and so on. And so the idea is to investigate this balance. On the one hand, what is the minimum of barrier material we need to reach the shelf life we want, but what is the maximal barrier that can be present without hampering the recyclability? So it's that balance that is going to be investigated. There we have another one, which is also a very huge trend at this moment in food packaging, is in fact the shift from plastics to paper. We can have a huge debate on that with advantages and disadvantages, but it is like it is, or the situation is like it is now. A lot of companies are considering the move to paper. But then there is a huge problem, in fact, that most of the paper need to be coated to give it a certain gas and water barrier. And we see at this moment a lot of companies are producing different types of coatings without, in fact, knowing if such coatings can be recycled or not. So this is the target, in fact, of REPAC. So REPAC wants to make an inventory of commercially available coatings. I want to test them for water vapor barrier, sealability, formability, and above all, recyclability. If it does not hamper, or if it hampers the recycling stream of paper and cardboard. I will go to another eco-design part, reusing. The reusing of packaging materials, which is also getting more and more important. Also, if you look to the European policy, reusability becomes also more and more important. And in that sense, there was a project also started last month. I will give a very practical example. Imagine that you bring this tray back to the supermarket, that you put it in a vendor machine, and then, like we do now already for bottles and so on, and that after that vendor machine, there are cameras. And for that, we work together with IMEC. IMEC is a huge technology center, worldwide known for its microchips, but also for making cameras and developing very sensitive cameras. Think about hyperspectral cameras and other types of cameras. And these cameras will check whether or not this package can immediately be reused so that it's clean enough, it has no scratches and so on. It will also detect if it needs to be washed, if there is still some contamination present, or if it's damaged too much, that it needs to be recycled. That's a little bit the idea as one of the first steps to try to introduce more reusability in, for example, a supermarket environment. With regard to renewability, I would like to give one example of a project which is recently finished, which is Horizon 2020 Innovation Action Project, like also MultiCycle is an innovation action, coordinated by the University of Montpellier with different partners, as you can see. For example, also Fraunhofer was partnered in this project. And it was focused on one of the, let's say, quite interesting bio-based polymers being PHBV. Polyhydroxybutyrate valerate, it's a copolymer of PHB and PHV, a family of the polyhydroxyalkanoates. Interesting about this material is that you can start from agricultural waste, for example, and that was the scope of GLOPAC, using agricultural waste that is fed into a fermentation installation, and by inoculating with specific bacteria, a polymer is produced inside the bacteria, which is the PHBV. The PHBV, after extraction, can be converted into plastic resins, and then, for example, you can use it in injection molding. That was one of the case studies in GLOPAC, together with the company Soridap, to, in fact, use these packs for fresh cheese. Another application was making sheets, which then are thermoformed and used for, on the one hand, falafel, a vegetarian product, on the other hand, fresh red meat. And that was in fact together with two members of Pack for Food. So both Pack for Food as La Vie est Belle, which is the vegetarian producer, as well as Colruyt, which is a big retailer in Belgium. We were all partners in this project. And one of the main outcomes of this project is that the shelf life of these food products packets in PHBV was in fact the same as the shelf life in the conventional crude oil-based plastics. So we hope that in future we can have more of this PHBV and other types of bio-based polymers on the market, not because they are compostable, but for most of all they are bio-based, and you use in fact side streams or waste streams to make in fact new types of packaging. And in some cases, of course, it can be beneficial that they are also compostable. All right, the last key message, of course, is recycling is important, but for that we need collection sorting. I think that was made very clear this morning, so I will not going to talk more about that. But what I also would like to stress out is what Peter was mentioning, is that collaboration is key. We want to have collaboration between different stakeholders. And for that, we have in fact initiated or took the initiative together with different partners, as you can see here in this, on this slide, to build a consortium collecting, in fact, different food clusters and packaging clusters within Europe in a so-called S3 platform, which is a European instrument to increase collaboration on a certain topic, to also install living labs on a certain topic. So in the first phase, we have contacted different clusters to be part of that. It is still under review by Europe, so we hope soon, normally this month, we will know the result, if this is approved or not. Once it is approved, we will also, of course, make the connection with the research institutes, with companies to also join this S3 platform on food packaging. In fact, to join forces to work on more sustainable food packaging throughout by bringing together different expertises and experiences. And so, like I have said, the aim is to establish a European collaboration platform to install a network of living labs on food packaging. So, being said that, this was in fact the end of my presentation. Looking forward to questions and also to the further networking moments. This is the Pack for Food team. We are with 6 enthusiastic people working and supporting companies on innovation in food packaging. And I also would like to announce that we celebrate quite soon our 15+2 years birthday on a physical event, the 28th of April. You can find more information on the website. So if you would be able to join, you can inscribe. So feel free. And thanks again for the invitation. And thanks for the attention.